Hello class, my name is Josh and I am part of Team Choking Hazard, where we'll be covering eutrophication in the Gulf of Mexico. Personally, my choice for picking this topic was I'm really big into following all the climate data, all the climate science. I've been doing it for years. It's part of the reason, I felt so moved to come to ASU in the first place to study sustainability. And out of all the ones in the list, eutrophication was the one I knew the least about. Didn't really know much about it at all. So having pick this topic, it's going to give me the chance to really, really delve deep into it. I'm really passionate about it, really passionate about learning new things. And so really excited to get started on this and show you guys a little bit of what we learned. In the next couple slides, you will see my team members explain what eutrophication is, what wicked problems are, and why eutrophication in the Gulf of Mexico is a wicked problem. I hope you guys enjoy it, and I hope you guys learn something new. Thank you. Hello, class. It's Josh again. Before we talk about eutrophication, let's make sure we understand exactly what wicked problems are. And as you can see, or as you saw in the last slide, wicked problems are unique in the sense that they're hard to define. The reason for that being is they're multi-system. They're just a complex ecosystem of multiple layers. And you can't really think about solving a wicked problem without realizing the consequences, whether intended or not intended, that you're going to have naturally because it affects so many things. So they're hard to define and even more difficult to solve. It really brings to question whether they're even truly solvable. And it really changes our perspective on what a solution is, right? Because we think about a solution being something you fix it, right? Can a wicked problem truly be fixed, or can it just be mediated? What I wrote about in my first essay, which I think is a pretty good comparison, is wicked problem is a little bit like a hydra, where you chop off one head and you get two more. So we have to be aware of these things with any proposed solution for issues like this.
Hello, my name is Corleone Mascareñas, and I'm taking sustainability courses to learn more about the topic in hopes of contributing to solving some of the problems humans have caused for ourselves. Now, our group's name is Choking Hazard, and this is a fun way of describing what our wicked problem is based on, and that's eutrophication. Eutrophication is where extra nutrients, typically from industrial farming, seeps its way into a body of water, and with the excessive nutrients in the water, this leads to algae blooms. Not normal cyclical algae blooms that happen in bodies of water such as the ocean, recurring seasonally. Instead, the extra propagation of algae literally chokes the body of water of oxygen, causing a mass die-off in the affected area. This is currently going on in the Gulf of Mexico from American industrial farming. And now the nutrient runoff seeping from the American heartlands into the Mississippi River and then subsequently being deposited into the Gulf. In the previous slide, you can see the image with color enhancement that shows the affected area called the dead zone. The National Oceanic and Atmospheric Administration have been keeping data on the situation for the last 30 years, and the average dead zone has been about 5,000 square miles. But 2017, the dead zone reached about 8,000 square miles. This issue is important, it's complex and wicked, and my group partners will elaborate in more detail just how wicked this issue is.
Hello, my name is Donald Phillips, and the eutrophication of the Mississippi Atchafalaya River Basin, or the Gulf of Mexico, is a wicked problem because it has the vague problem definition because this issue has the propensity to affect both the local national economy and ecosystem, but also the global economy and ecosystem. Added to this widespread area of effect is the number of different entities that are involved with both the problem and any recommended solution. Eutrophication creates undefined solutions due to the fact that although a widely recognized problem, finding common ground between the individuals and the industries creating the environment that leads to the eutrophication, the industries and communities suffering from the effects of it due to disturbed ecosystems and food sources, and the many individuals who see the problem but either aren't affected by it or feel they aren't, is almost impossible. It meets the no endpoint criteria due to the fact of the financial burden, potential disrupted infrastructure from halted, restructured, moved farming and industry along the tributaries that feed into the river basin, along with the taxation that would occur in an attempt of cleanup and purging of excess nutrients from the ecosystem caused by these practices. The irreversibility of this problem is due to the prolonged historical and ongoing man-made environmental changes added to the current infrastructure dependency on the industries and practices causing these issues. This, along with the immense scale of the affected area and the total number of individuals and commodities that contribute to this issue or would be negatively impacted by any solution, leads to its irreversibility. The uniqueness of the eutrophication of the Mississippi Atchafalaya River Basin is due to the other similarly sized river basins not being a center of agriculture and industry in the same scale as what we have in the Gulf of Mexico. The Congo and Amazon river basins are facing similar issues as the Gulf, but due to our buildup over the history of our country, the Gulf has an entirely different impact on our infrastructure. The extended amount of time of the eutrophication of the Gulf of Mexico and its resulting hypoxia make this wicked problem meet the six criteria of urgency. Over the many decades of man-made disruption of the ecosystem and the numerous forms that have left us with a problem that needs to be addressed now before it cannot be addressed, the Mississippi Atchafalaya River Basin issue is currently fixable, but needs hasty action in order to limit the damage created and lower the risk of continued permanent harm to the lost ecosystems, food sources, and industry.
Hi guys, my name is William Anderson and I'm in the Eutrophication of Gulf of Mexico group called Team Choking Hazard. I picked this wicked problem because I grew up in the Chesapeake Bay, dealing with eutrophication from farming communities out there, and I also have family in the Gulf Coast of Texas dealing with this same exact issue. Lastly, I'm a big scuba diver, so promoting marine ecosystem biodiversity and protecting its populations are important to me. Lastly, our group Choking Hazard collaborated successfully due to use of the Google Suite programs such as Gmail, Google Slides, and Google Drive helped us communicate, keep in touch, and collaborate this entire project for you guys. We also used our ASU emails to contact each other and coordinate video chats through the program Zoom. And lastly, I hope you guys enjoy the project. Thanks.